Okay, today we're going to look at inverse functions. So our learning intention is we want to be able to define what an inverse function is, and we want to be able to calculate the equation of that inverse. Yeah. So some of the success criteria is we need to be able to define the inverse relation of a function y equals f of x to be the relation obtained by reversing all the ordered pairs of the function. We want to be able to write the rule or rules for the inverse relation by exchanging x and y. Note that I changed it from a function to a relation. So that gives you warning bells that when we're doing inverse, most functions turn to relations. In the function rules, including any restrictions, solve for y if possible. Use f to the power of negative 1 x. That's a notation to state that it's the inverse function. And I'll state it now, it's not the same as 1 over f of x or the reciprocal. They're very different. So the inverse function we write as f negative 1x, and obviously the inverse, the reciprocal function is 1 over f of x. Very different. Okay, so inverse function. So inverse is something that undoes or reverses the operation. For example, we get 2x equals 8. Well, the inverse of that would be x equals 8 over 2. Yeah, so to get back to x, we'd divide by 2. Or for example, here we've got 2 to the power of 3, that equals 8. Well, the opposite would be the cube root of 8, which would equal 2. Yeah, so we're doing the opposite. We're coming back. So inverse function is find the function that reverses the original function. Okay, so I'll explain it as we go along. Okay. We want to find the inverse of y equals 2x plus 1. So we want to do the opposite. So let's try to make x the subject. That's what we're going to do. Try to make x the subject. Okay, so I'd bring the 1 to the other side, and then I'd divide by 2. Okay, but if you look at this, this is a linear equation. Okay, we've got a linear equation here where we've got 1, and we're going up 2, cross 1. Okay, got a linear equation there. Okay, and I'm trying to find what undoes it. Yeah, and I'm getting this x stuff. We want an equation for a line, basically. We want another equation. So what we need to do is we actually need to swap at this stage. Swap the x and y. So it ends up being y equals x minus 1 over 2. Okay, so now that I've got x values, I can figure out where it is. So for example, if x was 0, would have negative 1/2. Yeah. If x was 1, that would be 0 divided by 2 is 0. Yeah, we get something like that. And if obviously with 2, we get 1. Yeah. So obviously my sketch isn't wonderful, but we get another line that undoes it. Okay. So our syllabus has this statement. The inverse relation of y equals f of x can be found by interchanging the x and the y of the functions, and then making y the subject. Okay. So, and that's usually an easy way to do it first. So we want to find the inverse of this again by swapping x and y first. We're going to swap it. So that y becomes x, that x becomes y, and what we're now going to do is make y the subject. Yeah, so I minus 1 from both sides. I get x minus 1 over 2. Just flip it around. Okay, and there's my equation. Yeah, that's the same equation as here. Yeah. Whereas here I had to swap the x and the y at the end. Here I swapped it right at the start. Yeah. So my solution already is in the form that I want. This tends to be a lot easier for much more complicated problems. Okay. All right. So we're going to find the inverse of y equals x squared minus 2x plus 1. So this is a parabola with which we have x minus 1 all squared. Okay. And before I do that, before I find the inverse, I just want to just plug in these values for this into this equation. So I'll use this factorized form. 1 minus 1 all squared, that's 0. 2 minus 1 is 1. That's 1. 3 minus 1 is 2. That becomes 4. 4 minus 1 is 3. That's 9. Minus 1 becomes 1. Minus 2 minus 3 becomes, minus 2 minus 1 minus 3 becomes 9. Because that should be negative 1. I missed out negative 1. So let's just say that was there. All right. And then negative 3 minus 1 is negative 4, 16. And that's 25. Okay. Okay, so this is obviously f of x, the original function. So let's practice the inverse. I'm going to swap first. Swap x and y's. So it becomes x. We've got y squared minus 2y plus 1. And as we said, that's a factorized form, so we have y minus 1 all squared. Okay. Now, the opposite of a square is obviously the square root, so that's plus or minus x. Yep. Y minus 1. Well, making y the subject, we have 1 plus or minus square root x. Yeah. So the inverse of the function is 1 plus or minus square root x. Okay. So let's do 0. So the square root of 0 is 0, so that becomes 1. Let's just use the positive versions. So square root 1 plus 1 is 2. Square root 2 plus 1 is 2.4. Square root 3 plus 1 is 2.7. And square root 4 plus 1 is 3. Okay. And obviously these values don't exist. You can see from some of the values, the ones that create real integers, okay. For example, these ones, 1, 0, 2, 1, 3, 4, they actually flip when we're doing it on the other side. So what we get is 0, 1, so that's flipped. 2, 1 or 1, 2, that's flipped. 3, 4 has been flipped for 4, 3. And that's what we tend to find. We tend to find that the inverse will switch the coordinates around. Okay. Obviously, because we get a plus or minus square root, it doesn't work perfectly for these numbers. But some of the key points, the x swaps for y, the y swaps for x's. Okay. Some more examples. All right. We want to find the inverse of f of x being x cubed. So f negative x. Okay. So we've got y equals x cubed. Let's swap them around. X equals y cubed. The opposite of cubing something is doing the cube root. So this would be the cube root of x. Okay, and we want to know what it might look like as x is greater than 1. Okay, so here is our function, or here's our Cartesian plane. If that was 1, the cube root of 1 is 1. Obviously, the cube root of 8 is 2. So you'd get something like that. Okay. And that's basically what's the inverse. Well, we still produce a result. It's just the cube root of whatever x might be. Okay. Now we're going to find the inverse function of f of x, x plus 2 all squared. Okay, so that's y equals x plus 2 squared. If we swap everything around, yep, I do the square root, which is plus or minus, because it's an even power, and I get y plus 2. So y must be negative 2 plus or minus the square root of x. And if we wanted to think of when x is less than 2, all right, so if we had 1, the square root of 1 is obviously 1, so negative 2 plus 1 is negative 1, and then negative 3. Yep. If it was square root 2, we'll just plug it in. So negative 2 square root 2 plus square root 2 is negative and half, so somewhere here. And obviously if we're going to subtract it, it's negative 3.4, which is somewhere here. And if it was 0, it would be negative 2. So you get that. And we want it equal, so it would be small dollars. And that's what the inverse would look like. So inverse of x is negative 2 plus or minus the square root of x. Okay. Let's calculate the inverse of this one, and I'm going to state the domain and the range. Okay, so once again, we've got y equals 9 minus x squared. To get rid of that, we'll swap it straight away. So 9 minus y squared. I want to square that. All right. I can make y the subject, but I'm noticing that if I bring this y over here, I get this equation, which is a circle with an origin at no, with its center. Sorry, with the center at the origin. Yeah, and the radius of 3. Yeah, so you do the square root of that. Yeah, so I have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, something like that. Yeah, so the domain, and it's restricted, they only want from -3 to 0. Well, the domain is obviously going to be inclusive of -3, and it can include 0. We get 2 values, but yeah, it does include 0. All right. The range between these 2 points is 3 and -3. These are the values that we get. So it could equal -3 and it could equal 3. Okay. So looking back at our notes, we need to be able to define the inverse relationship of a function. Yeah. So by swapping, they become the order pairs swap, and by swapping x and y, we get the function. The inverse function is written by f to the power of -1 over x. It's not the same as the reciprocal of 1 over f of x, just so we know that. So we're able to find the rules and then use that to graph our new function. Cool. Thank you very much. Bye.